We are looking at confidence interval for the population mean using the t-distribution. So let's read this. A researcher collected sample data for 20 women, so that's going to be our N. That's how many total women we're looking at, from ages 18 to 24. They had a sample mean serum cholesterol level of 191.7 with a standard deviation of 5.1. Assuming their serum cholesterol level for women ages 18 to 24 are normally distributed, find a 90% confidence interval for the mean serum cholesterol level for all women in this age group. All right, so what we're looking at, the first thing we want to do is figure out our t-value that we're dealing with. Okay, so the t-value, kind of like the z-score, is a curve. This curve is a little different in the fact that it's a little narrower and taller, but it works kind of the same way. So we're going to use our calculator to find this value. We want a 90% confidence interval. So basically what we're looking at is we want 90% of this curve, this t-curve, to fall in the middle here. Okay, so to be 90% confident, we want to fall somewhere between here. So if I'm 90%, that leaves us, so 90%, let's do 100% minus 90%, that leaves us with 10% left over. So this area right here from here to here accounts for 90%. I need to account for the other 10%. So what actually happens is we're going to divide this by 2, and we're going to put 5% here and 5% here. So when we go look for this on the calculator, we're actually going to use t.05, okay? And this is going to be the same number, but since it's on the left side, this is going to be the negative of our t.05. All right? So this will give us our lower bound and our upper bound values. So it gives us a range for our confidence interval. All right, so let's go to the calculator and look at this. So we click on the calculator and we find the t-value, and we're going to do 0.05 because we want what's left over from a 90%, 100% minus 90%, and cut it in half. To find the degrees of freedom, which what that df is, we look at n minus 1. So we take how many things we are surveying. Here it is women, so we got 20 women, so we do 20 minus 1, and we get 19. Okay, so our t-value that we are going to use is 1.7291. So I'm actually going to store this because we are going to use that twice. All right, so we put that t-value aside. So now we have our t-value. So we have our curve. We have our number that we're looking at. It is 1.729 on this side, and this side is going to be the negative of that since we're talking about negative side here. And we're going to figure out what our confidence interval based on that. So if we have a mean of 191.7 and a standard deviation of 5.1, our formula that we're going to use is we want to do the standard deviation divided by the square root of n. Okay, so that's kind of like our margin of error here. So if we do that, we're going to do our standard deviation, which is 5.1, divided by the square root of n, which is 20. All right, so let's go back to the calculator and figure out what this number is. So we do standard deviation 5.1 divided by the square root of n, square root of 20, and we get 1.14. Now what we're actually going to do with this number is we're going to take it times that t-value that we have there. Okay, take the t-value times that, and I'll write the formula in just a second. So we're going to do this times the number that I have stored, and we get 1.791. All right, so what this formula is looking like, so what we actually do is t times the standard deviation divided by the square root of n, and this is going to be what we call our margin of error. Okay, so we're going to do this number, and this is what we get. We get 1.972 for rounding. Now, to find our actual number that we're going to look at, we take our mean. We're going to do our mean plus and minus our margin of error. Okay, so this is what I'm calling capital E for margin of error. So we do our mean 191.7 plus that 1.972, and then 191.7 minus 1.972. And this should be our answer for our 90% confidence interval. So again, the thought process of what we are really doing here is we're just doing a survey of 20 people, but we want to know what happens if we go ask all women what their average serum cholesterol level will be. So we don't want to say it's going to be exactly 191.7. We want to give ourselves a margin of error. So we're adding almost 2 to this. So we're going to say, okay, it's going to be somewhere between like 189 and 193. So let's go get those exact numbers that we have here. So I'm going to take this number. I'm going to store this number actually because we're going to use it twice. So store it. And I'm going to do 191 plus 191.7 plus the number that we have there. So that is 193. So that should be our upper limit. Okay, that's a higher number, so that is the upper limit, 0.672. So this is at least 3 decimal places, so let's make sure we do that. I'm going to do 191.7 minus that number that we have there, and that should be my lower bound. 189.728. That may not seem like that big of a range, but since we have a 90% confidence interval, we're saying, there's a 10% chance we're wrong when we go ask everybody. So let's make our range real small. So we're going to guess that it's somewhere between 189.7 and 193.8. And that gives us some leeway there. And there's a 10% chance we're wrong anyways, because we're just 90% confident about that.